Hello everyone, welcome to this stream. Today we will be assembling the iCEBreaker bitsy, which Jordi designed in the previous stream. So I showed it off together with Glasgow in one of the previous streams, the changes that Jordi did to this board. So first of all, iCEBreaker as a platform is this thing, which is and I should be using the desktop cam for this. So this is the iCEBreaker, which is an ICE40 up5K FPGA development platform and teaching platform. And we wanted to have a smaller version of this that can be used easier as part of smaller projects, as well as being able to plug into a breadboard for prototyping and playing around. So originally I made this board, well, in different order, but anyways, there's like three revisions that I worked on. Sylvain pulled this one together, and the main thing, the main difference is that it is just the ICE40 up5K that does USB communication on its own, and it has a bootloader built in that you can program the bitstream using USB directly. So it should be also slightly cheaper because it doesn't have the FTDI programmer chip. Also, it has some pluses and minuses where you need to have the USB stack in the FPGA if you want to communicate to the computer over USB, but you don't need the FTDI chip, so you can do other things than just standard serial or SPI interfaces. So it is a little bit more flexible. So it is a give and take thing here. It should hopefully make the board slightly cheaper, as I said before. And while I was working on the Glasgow, which you saw in previous streams, which is this guy, Jordi Parque Rodriguez, who is so focusing better, that's good. So he designed this board based on some requirements that I had in the back of my head, and he blew it certainly out of the water. So this is this board. And multiple changes happened. Yeah, that's him. 0xDC. That's Jordi. And so we will be assembling the boards today. And so this is how it looks. One of the main changes we made between the previous revision and this one is move the PSRAM chip to the top of the board. We changed the USB connector to be USB-C. Yay, be happy. Be happy, people, you get USB-C. We squeezed a bunch of additional parts. Jordi did all of that work. So Jordi also moved the oscillator around to the other side of the chip, compressed a bunch of stuff. So watch the previous stream where we made an update and Jordi called in and he explained all the changes that we did to the board. I find this castellated holes a great idea. It is based on a design for an Arduino, and this board is much more compatible. Was that suddenly going dark on the BOM page? I don't know. It shouldn't be going darker. Let's see. Definitely Twitch. What is Twitch doing? So it looks fine here in the preview. There might be some issues. It's like I had issues with the HDMI cable, and it's like... Oh, I see. So basically, if you full screen Twitch, and you let your computer, so your computer goes to sleep essentially. Yeah, I've seen that in some applications that are not keeping the computer awake. It's weird. YouTube should keep the computer awake, and Twitch is sometimes not doing it. That's weird. But yeah, that's a separate issue. All right, so this is HTML bomb. I'm trying to think. It is mostly covered here, but yeah, let's see. We can organize it differently. Like this. Will that help? Like this. So yeah, so this is the board and these are the components. I did hopefully pull out everything out of my stash, and we should be able to quickly assemble it. I did clean them up, so this is when they come from Usbc. Let's see. Whoop. Yeah, and I need someone with optical tube skills here. So yeah, it's not sharp in some cases. With the camera and the microscope setup, that's something I have to work on too at some point. All right, so I did use a file to get rid of the tabs that are just randomly on the edges. So you see a little bit of scuffs here. And then the castellated holes are not, I'm not sure they are officially supported or listed as supported, but you can still make them. They will cut through them. And what I didn't show you is yesterday I went with a scalpel and removed the tabs of metal that are being folded over by the milling bit into the castellated hole. So they need a little bit of cleanup after you get them from Usbc. In this particular case, the holes look great. Sometimes I've seen, especially on smaller pitch castellated holes, that the vias, the material from the inside of the hole sometimes gets lifted out a little bit. So you might get a little bit of a hit and miss. Yes, exactly. So yeah, anyways, at the end, that's how they look, and we can now have the footprint. I don't know what I will do with the programming. This will be an interesting thing. So yeah, we have to change language here. Haha. Anyways, I probably will have to have a pogo pin thing for programming it to put the bootloader initially on. Closely followed, yeah. So Usbc, when you ask them, they will tell you exactly what I told you. So it is vendor vendor supported or vendor encouraged, with the caveats. It's like, well, sometimes you might get a board that has an issue, and I am fine with that. That's why you get 3 of them and not 1. And then one of them should be fine, and that's good enough for my purposes. So yeah, anyways, yeah, and I already, let's go here. So if you're wondering what these are my markers when I do assembly of a product. I use these as markers when I have boards that need rework. No, it shouldn't. The current Git, I think we merged it. Slightly different? Oh, definitely the logos are the null logos on in the page. So I do replace the logos. I do not publish the boards on Git with the 1-bit squared logos. But otherwise, yeah. But otherwise, there are anchors called null. So you see that here in the desktop. Oh, it is missing on the top? It should be there. Maybe it is. Yeah, I thought I had that there. Okay, I will check. There might be some inconsistency there. Okay, so we have the stencil. I already placed everything. It is nicely aligned. I did check it with a loop. I have my solder paste here. Ah, okay. I have to merge something. Ah, of course. Yeah, after the stream, remind me to merge this stuff correctly. Also, it's like I was planning to have one of them to send to you, Sylvain. So it's like you can also wait and get one from me. So unless you just want to build it yourself, that's fine. Do you have a particular preference process with respect to making your stencils? Yes, right. So I get my mine from. Fair enough, Sylvain. Okay, so these are our stencils. I prefer our stencils. I did get some from LCSC. They are very much hit and miss. Sometimes they work, sometimes it's a nightmare. That's why I prefer to order this stuff from Osh stencils, because they're at least consistent. And I can get them quickly. They are more expensive, but that's fine. And otherwise, I don't know, there's probably a litany of things that I try to think about, but you would have to ask me in situ when I'm making them. Yeah, so solder paste and mix the solder paste. I pulled it out like 2 hours ago to warm up. I keep it in the fridge so that it doesn't go bad as fast. And most soda paste requires to be stored in cool environment. There are some soda paste that can be stored outside explicitly. They have a different, I think, flux formula. But yeah, so this is. So there are two. So also you have to keep in mind, Osh Stencils is not the same as Osh Park. So Osh Park, they are two separate companies, but they both are really awesome. So so the PCBs are from Osh Park and the stencil is from Osh Stencil. They just happen to share the Osh prefix. Yeah. Yeah, Osh Park also uses multiple different board houses by now, so they did change them. I'm not exactly sure who they are using at the very moment, because that was changing over the years quite regularly. Okay, that should be enough. That's more than enough. So I put the remainder into the I don't waste all of it. So you don't have to skimp. Skimping has the problem that you get voiding, and then you so the important thing is it has to be enough so that you get good coverage, and you want to do it in one swoop. I keep seeing, it's like, again, this last week I saw one of the electronics hacker makers. He put like a tiny bead of solder paste on the corner and was squeegeeing like crazy 50 times over this thing to make a full coverage. And then you get those like really bad squeeze under the stencil. I keep repeating that every time I do stenciling here. One swipe, not more. If you fail with one swipe, clean the board, do it again. One swipe, and every time I am lazy. I just did Blackmagic Probe assembly recently, and essentially I was too lazy to redo, I think, the one of the connectors, and then I swiped over like second time, and that board had a bunch of shorts. So after reflow. So yeah, if you're lazy, you will have a lot of rework additionally. So yeah, I work it like this. I work it between two squidgies to spread it out and make a nice bead. I have a nice bead now, and the board is here. And then slow swipe like this. And then we should have it. Ta-da! It's really difficult. This is a small board, so it's very easy to... Okay, let's see how that looks. Come on. There. Let's see. Will that work? There we go. So yeah, that's the result you get. Yeah, it looks nice. Porti. Calling Greg DeVille. Yeah. His are sometimes crisper. I think my soda paste, the flux is more liquid than his, so his is keeping more of a square shape on the pads than mine does. So yeah, there you go. So that's one. We will do two today, just to not waste too much of your time. I will do the rest later. I have 9 PCBs here. There we go. Let's switch back to here. And there we go. Just work it once. And there we go. 2. And we are done. Yeah, I'm not doing more than that because I don't want to make you sit here for me assembling 9 panels, 9 boards. So there we go. Let's see if that looks good. So yeah, so this is the interesting part here. On the second try, it's looking a little bit different because I didn't follow my own recommendation of actually doing a small wipe on the back of the board, of the stencil after each board. It's not difficult for manual application. And yeah, my finger is dangerously close to the pads here for the pull-up resistor. But yeah. All right, so that's it. Right. Yeah, that's true. That's a good point. It's really difficult for me. I keep working on improving my video and sharing setup. So I hope over time I can make this look even crisper and better. So my current main thing I would love to upgrade is the microscope camera, and go to the Sony IMX or whatever camera, which has built-in focusing, autofocus and stuff. The quality of that, from what I've seen, is really marvelous, and that's my setup dream. Hopefully, at some point, I will be able to afford buying that. So yeah. And this should help with some of the visuals. So see, it's like this. Like I still will have to focus a little bit, but the camera will take care of the last a little bit. There's also some issues with like the alignment. The depth of field is a little bit shallower than in the eyepieces, because your eyes can also focus differently. It's anyways. Okay, solder paste. Let me clean this really quick here. I can put this away. Let's get a stencil wipe. So these are IPA infused wipes. Okay, I will look it up in a second for you, Sylvain. So I know Lost on Twitch. He was streaming recently, and he bought this on AliExpress, the Sony IMX camera with optics, and god damn, this was a good quality. I was like, oh, I would love to have that kind of quality. And he was like, yeah, I just bought this. Did they again? Yeah, they might have stepped it up again. It's it's an issue that happens. I thought they fixed it, and they might not have fixed it. I think it is again broken. Oh, you have the IMX one, right? Okay, so you did get that particular one. Okay, cool. Yeah, it is really high quality, and usually you get it with the whole optics system. And yeah, I would probably buy the whole optics system version and then probably move the camera on my microscope, so that I have the option of using the downlooking stuff, because it's the optics. The version without the optics and the version with optics is not a huge price difference, like $50 difference or something ridiculous like this. So I probably will get both. Yeah, I have to look it up. I have it somewhere. So let's see. Let's do that really quick. Come on, mouse. You can do it. It's Sony, just really quick, Sony yeah, it's IMX 183, I think. Let's see if I get the right link, and then no, it's okay. No, 290. Ah, there we go. That's the number. 290. Yes, that's the correct one. So let me share the screen here. Yeah, so that's the, yeah, and then autofocus. Yeah, so there's plenty of, I could not decide which one to get from which seller. That's the problem. Otherwise I might have actually gotten one by now, but yeah, they are not cheap. Yes, $500. So, oh, with the stand they are actually much more expensive. So they are $400. So it is 100 and a little bit over $100 with the all this stuff. So for the optics, I guess. But yeah, I think it still makes sense to get the visual one. I don't know. Something. I will have to decide which one I get. But yeah, this is basically what you're looking at, and the quality of what I've seen on Lost Channel, it was just, oh my god, this is good. Okay, cool. So we have solder paste on here. Oh, I should clean my spatula here. There we go. Chook, chook. All right. So now let's start. Let's get my thingy here. And we will go on to iCEBreaker bomb. And then we will go on microscope and zoom out. Focus a little bit. There we go. Not long. So I am ignoring the fact that I should be. So for assembly on the pick and place machine, I try to not have it on the panel stenciled for longer than, I'd say, half an hour to an hour at most. It's not a. This part is not as much of a huge deal. I have not seen a lot of variability. Let's call it that way. It was not a big issue yet. I'm sure it has impact on consistency, but it wasn't too much of an issue so far. But for like assembling boards, it's like I sometimes, it takes me most of the day to assemble a board, and it's like, it is what it is, and it does get like crusty and dry, and it's not sticking anymore. But the reflow, after reflow, it is fine, and it's hand assembled, so you push the parts into the board nicely. So, but yeah, so the working time has not been too much of a problem so far. Okay, so let's start with the. Oh, I should be showing you the preview here. This is the desktop screen capture. Is that the screen capture? Yes, there we go. And this guy, let's do this. Like this. So you have a little bit of a preview of what I'm doing here. We move this out of the way. So I have my magic box. And we have 100 nanofarad is the first thing that we will be assembling. Yeah, the tiny logo. Yeah, but this is Usbc. So this is the quality of the Usbc PCB manufacturing. The resolution is just insane. It's not possible to get it from others, unfortunately, yet. Because it's like, even though Drew is saying it's like a 1 million DPI or something, or 10K DPI, it is too smooth for that. I don't know what the process actually is. I would want to know, like, what is the actual machine that you're using for this process at the factory, and then like tell a vendor that doesn't charge that much for PCB assembly, PCB manufacturing. Anyways. Yeah. Alrighty. So, why is this? Oh yeah, there we go. So, I should move this out of the way. I have to focus the eyepieces because they were out of whack. Yeah, that would be very useful information for me. Because so far we only got like, oh, the quality is this and this is the resolution, and it's like, yeah, but the other machines claim the same and it's not the same quality, and my tweezers are sticky. God damn it. I might need to degauss my tweezers. I'm not sure if it is actually dirt and stickiness or if it is magnetic. And yeah, let's try it again. Okay, that works. Sorry, I'm trying to... Yeah, they are stainless steel tweezers. These are the RM tweezers that I have listed in my tool list, I think. Trying to track which parts are which. Come on. It's probably again out of sight now. It's actually not, surprisingly. So another thing for my microscope setup that I would love to fix is to get an optical, like a glass inside that is etched that shows me what the view area of the camera is. So basically, in my field of view optically with my eyes is much larger than the one with the camera. So it would be nice to have like at least a square that shows me what the camera actually sees. Usually it is done somehow with like an etched glass, and I have no idea where you put it in the optical path. The problem is, yeah. Oh, yeah, interesting. I think it really depends on what exact alloy it is, because stainless steel can also be of a grade that rusts. So in like when you have it in contact with salty water and not rust at all. So it's like it really depends on the grade and the exact alloy. Like considering like SpaceX and their space Starship or whatever it is called. Yeah, Starship, I think. They also are now working on developing their own alloy for the purpose, specifically for purpose, which is pretty impressive, in my opinion. Okay, so where were I? There. Skip. And skip. Is that the, yeah, to skip. Okay. And then over here. Is this? Still not sure if this is properly focused. Three, yeah, I think I missed one. Yeah, you're right. You're right. I might have missed the vertical one. Yes, I did. The vertical capacitor here on the right side on the other board is missing. I even see it here. Thank you for pointing out. Ooh, there we go. And then let's go down. Oh, we have these two too, and so I need a few more. Come on. Okay. Vitamin Gestek. Good eye. I see you're paying attention. That's... There we go. So that's fixed. Okay, so we have 1, 2, 3, 4. So it is. It says here 9. There should be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. So that's done and placed. Next one. 1 micro. We need 3 per board. Oh, I should put these back in. Don't mix parts. There we go. 1, 2, 3. 3 and 1, 2, 3. Good. Ba-bam. Oh, I think I need wireless headphones or something. So annoying. There we go. Where do they go? This goes here. One. I love how the windowing on exposed pads looks. Windowing? What magnification level is in scope at? It's like, yeah, it is. It is. So basically, I have a half reducer here, then I have 0.7 here, and then I have 10x here. So multiply that out, what that is. So it is 10x times 0.7 times 0.5. And the camera itself has a 0.5 here, then it goes through the 0.7 and the 0.5. This is weird. I think there is also some magnification here. I'm not sure. And then it crops, so it doesn't have a full vision, which is a separate problem. Really like my Jabra 65Ts. Oh, the wireless headphones. These are, I don't even know that the brand. I do have like over-ear Sony noise cancelling that I don't use headphones. That I use the headphones without the noise cancelling because the noise cancelling makes me dizzy. I don't know. It's seems to be few people sometimes have that issue with the noise cancelling, and it really makes me like, oh, woozy. So I have to switch it off, unfortunately. It's really annoying. I wish the noise cancelling was working for me. It's like I feel like a pressure on my ears when I switch it on, and it makes me dizzy. Which version? Oh god, they're from like last year, I think. So it's like 1 generation old. I think. We bought them before tour camp last year. That's what I remember. Okay, so I missed one again. It's this one on top. Yeah, 1000 MX3s, I think. I have them over there. I could pick them up, but... Okay, 10 nano is the next one. 10 nanofarad. We need just 2 of them. 1, 2, and 1, 2. And they go on top here by the plus. And on the bottom here, by the cluster, come on. Okay. Foam earplug style of headphones. That's interesting. Do you know the brand or like a model number or something? That would be interesting. I would love to find one that actually, yeah, I'm sure it is very human dependent. It's like for some reason I'm sensitive to it. I know others that are not sensitive to it. And the weird thing is, I have a friend who is using the noise canceling headphones all the time, and he doesn't get woozy with the noise canceling, but doing VR, I'm not getting dizzy where he does. So it's like it's a reverse thing here, depending on where you get dizzy or not. It's so weird. Yeah, Comply Foam ear tips for most brands of earbuds. Okay, cool. So yeah, maybe I should just get better quality headphones. That's probably the solution. All right, so that was 10 nanos. We are having like two conversations here, so it's a little bit more harder to keep track of things than usual for me. So 4.7 in 0603. Oh my goodness, we have a bunch of them. So this is the input and output filter capacitors for the voltage regulators. 3 and 4. Radio Shack used to sell them 15 years ago. Yeah, so the best headphones are those that you bought like 15 years ago and they still going strong, right? For like listening casually, I still use this Sennheiser foldable headphones. Like I don't know what the model is, but I kept rebuying them, and they stopped now making them completely, which is really a bummer. The problem was the cables keep breaking on them, but the quality of sound is just so good, and they are over ear, and they don't make my ears sweat, which the over ear stuff always does. I like the on ear. I prefer that to the plugs or the full over ear ones. It just feels less stuffy somehow. Closed pressure. I understand that at some degree. Yeah, it really depends. It's like I think everyone has their preferences there. This is like very personal experience. Open back earphones? No, I have not. I should probably try that. The problem is with headphones, it's like, yeah, I felt grossed out trying them out in the store before COVID. And you only get a short test where it's like, oh, how do they compare? And you actually would have to be able to, I don't know, rent them for a while to try out and figure out which ones works for you. So it is a huge money investment to basically buy headphones and keep buying headphones until you come across those that work for you best. But yeah. Yeah, I did not try the open back ones. They might be actually a good solution so that my ears don't sweat. So I should give them a try. But what I'm really confused by is that no one is making the small, lightweight, on-ear headphones that are wireless. It's like, it doesn't have to have, like, if you can make in-ear plugs that have a long battery lifetime, why can't you make those normal on-ear ones wireless that have a decent runtime? It's like, for me, this is a niche that exists there, and it just doesn't exist. For some reason, everyone decided full on-ear or open back on-ear. Yeah, they do. They are huge. Yeah, you got it. It's like 0603 is massive. Yeah, okay. I have not found anything, Sylvain. It's weird. I am happy to be corrected. All right, so that was the 4.7. Then we need the 10 micros. We need just one per board. Where is it? It's here. Oh, there's an LED floating around here. That's not good. Chunker. Yeah, it's interesting. Oh, I have to look at this. Yeah, maybe. Okay, so resistors, finally, 10K resistors, a bunch of 10Ks. How many do we need? Oh, just 3. Okay, all right, fine. 1, 2, 3. 1, 2, 3. There we go. So this is actually the sequencing circuit here, as you can. So this RC network is delaying the power on. Okay, all right. That sounds. I will have to then do some research, I guess. The blue headphones on the girl in the gym. That's the brand. All right, so that's 10Ks. And we have this here, 1. This is annoying. I have this highlight here. That is really... There we go. That's better. It's overlapping in my preview here. This is an 0402 resistor. Yeah, they were... Yes. So there are some capacitors 0603 and LEDs are 0603. Correct. Bam. Right? Yes. And that's the pull up for the button. There we go. Don't jump. Oh, sorry. This was here, down here. So there are two. So for this particular footprint, there are two brands on LCSC that sell this footprint. The one on DigiKey has a different pinout, so it's not compatible. And so you have to be careful which one you use. The DigiKey is pin incompatible. It's like the this one has D plus. It's like, what is it? D plus, D minus, D plus, D minus in the pinout, and the one on DigiKey is D plus, D minus, D minus, D plus, or something like that. So it's fairly annoying that the one on DigiKey, the pinout is easier to route in most cases, but the one on LCSC has two vendors that sell that footprint. So that's for you to figure out which one is better for your design. But the footprint itself is pretty much the same, I think. It's just the pinout difference, which is bad enough. All right, so 5.1K. Now that will be interesting. So these are the two pull downs. Yeah, pull downs for the C1 and C2 lines. This is the thing that Raspberry Pi screwed up, as we talked about it in the past, where they connected only one resistor to both C1 and C2, which causes issues that the cable orientation cannot be detected when you plug in a USB-C to USB-C cable. You need those two resistors for that. Okay, that's one. That's two. It's not missing. They designed the circuit so that they thought we just need one pull down to pull both. So essentially, they connected this pin to this pin together and then one resistor, instead of having two separate resistors, one here and one here on these lines. You have to have them separate because that's how it detects which orientation the cable is plugged in, by pulling one up and then pulling the other. I don't exactly know how it works, but yeah, essentially. Oh yeah, thank you, Jordy. Yeah, that's the article, I guess, that describes the issue. Okay, 22 ohm. So these are the inline USB 2 resistors. It's normal. 2, 3, 4. Yeah, well, we will learn about this weirdnesses over time as this standard becomes more and more common. Still, I'm annoyed that yeah, no, I'm not really annoyed. It's like this is the amount of necessary work to get this USB-C connector to work is not end of the world. I admit it now. Especially with the lower pin count connectors that are just USB 2.0 connectors and not USB 3 capable. I think that's reasonable. Yeah, well, you need to then support the protocols, I guess. But yeah, as long as it is as simple to actually use the USB-C connector itself as it is here, I'm fine with that for USB 2 only devices. When USB 3 comes, that's a different story. This is quite a complicated thing with controllers and high-speed muxes and stuff like that. So, but that's the price you have to pay for 5 gig speed. Multi-host. USB-C is, at least on paper, something we've had since 2016. Yeah, I know it, but this is with all standards. It takes a long time before it actually becomes. It's like these connectors are also very new. They are like, they didn't. This kind of connector didn't exist like a year ago or something. At least not to my knowledge. Yeah. Well, maybe a clean slate design would help, but yeah, it's a consortium that is like driven by a lot of voices, so standards. Yeah, it's like even new computers. But it's the nice thing about USB-C is in cases like this, I don't know. It's not a big ask for those that only have USB 2 connectors on them, and for those that don't, it's like they can use their USB-C power supplies and banks, so maybe they can decrease the amount of cabling that they have to carry with them. So I'm done with that discussion, to be honest. It's like we are now starting to use USB-C connectors on this. Fine, seems to be working. All right. It's like that's what the loudest voices wanted. Fine, whatever. I can make it happen. That makes a bunch of people happy. Good. All right. So next one. 330 ohm resistors for the LEDs. 1, 2, 3, 3, and one more. Come on. And 4. Yep. All right, there. Two. A thing that I learned recently, which was very interesting, is the history of micro USB connector. I didn't even realize that it was basically Nokia who wanted to compete with Apple at the very beginning before they completely tanked. They wanted something thinner to be able to compete. So essentially, Nokia was loud enough to force the consortium to add micro USB connectors. All right, so what's going on here? When when USB-C now or not now? Otherwise, I would have to spend. Thunderbolt and touchscreen. Yeah, I have not. I tried to use a touchscreen laptop, but it's like it's so easy to just tap on it and do crazy stuff. It was in my way so far. I basically disabled the touchscreen because yeah, I found it more annoying than helpful. How do you prevent yourself from like just randomly tapping on stuff? It's like maybe over time you learn it, I guess. But it's like, especially when you try to hold it when you're like in bed and you are watching something on a laptop, it's very easy to touch it on the screen. That was the most annoying part. So yeah, probably there has to be a toggle on off that is easy to access to switch on and off the touchscreen. But yeah, AMD. So my current actually the direction is regarding hardware. Yeah, it's definitely I want actually a desktop PC. That's my current like crave, is to get a proper desktop PC that I can do streaming from instead of this laptop. This laptop is doing a great job, but it would be nice to have a dedicated machine for it. That most of it is living under the table and doesn't take up so much space on my desk here, because the laptop takes up a serious amount of space here. Yeah. All right, next thing is 1 mega ohm, which is for the shielding case of the USB shield. Come on, it's sitting there, I only have a few here. They're sitting in the corner of the case. There we go. 1 mega ohms. Okie dokie. So I am very excited to send one of them to Kate Temkin, to see that Luna also works on this, which is the USB stack she developed. That's very exciting. Looking forward to that. And then also get the bootloader from Sylvain ported to this. I think the pins got changed, right, Sylvain? It's like, I think we need to make some minor changes here to get the bootloader to run on this version of the hardware. PCF change should be enough? Okay, cool. Because you were talking also about the differential pair stuff, like with the driver on this board versus the previous. This was a change I think you asked Jordi to make it better, or like be more, I don't know. This was something with the I/O buffer clocks. I don't exactly remember what the exact motivation was. All right, next one is 1.5 kilo ohm. This is the pull-up resistor for the USB connect disconnect. All right, so that's here. Pull-up resistor. 1. And 2. Okay. Next. 2.2 kilo. 2.2 kilo ohm. What was that for? I don't remember anymore. One, two. So previous conflicted with some exposed I/O, but since the bootloader doesn't use any of the exposed I/O, there was no conflict anyway. It's really only a concern when you have USB plus a user design using the exposed pins. Okay, so it is mostly to make it better when a user application has also a USB core in it, which is a good fix to have. Oh, that's the series at CDUN or CDUN pull-up resistor. Okay, sure. Yeah, this is a circuit that might want some revision in the future to make it easier. Maybe we can combine some BOM if we don't need specific value of the resistor here, because we just need one of those 2.2 kilos. All right, so that's done. Yeah, if we could use like 1.5K or something close-ish instead, that would be nice. All right, so 100 ohm. There we go, 100 ohm. And 100 ohm. There we go. Two of them in series, yeah, in theory, yeah. Two placements instead of one to decrease the part count. Yeah, it's a possibility. So 10 kilo, and we need only one of them, so we just need two for now. 1 and 2, so the pull-ups here. Ba-bam. This is okay. I need to zoom in here. Ugh. There we go. I have a little bit of a bump here, I think, under the microscope, so the boards are tilty, seesawing a little bit. All right, there we go. Okay, so that's done. Now we are to the diodes. All right, I need a very, very short break. I'll be right back. Alrighty, there I am. Sorry about that. Really quick break. Need a drink. Alrighty. So we have all the passives, I think, done. Now we can do the red LEDs. 1 and 2. I think there are just 2 of them we need. So I don't remember which way they went. Haha. Okay, I think ground is here. So let's see. Yep, so this way. The die is on the left. 1. And die is on the left. Yeah, so this is where the ground side would be, and I want the die on the left because it means that's where it is sitting on the die. It's like sitting on a, so that's usually how I check the direction, is by looking at the die inside the part, inside the LED. The green one should be easier to see. 1 and 2. this is clearer if I zoom in. You see here? Yeah, that's probably better visible. So you see the die, how it is sitting on the ground. So this is the ground pad. And the bond wire goes from the positive side. So we want, when we place it here, we want this side to go left. There you go. And then the second, yeah, I have to turn it around. And there we go. Can we zoom out again? Well, maybe like if we zoom in a little bit, it's better. There we go. It's slightly better, maybe. Okay, dokie. That's green. Now let's do the blue one. Blue. Should have still 2 LEDs left here. I checked yesterday. This is what I mean. It's like the streams take some preparation effort. That means I have to, for example, yesterday I had to clean up all these PCBs, I had to set up the stencil, I had to go through all the parts, make sure they are available. We have everything so that we can do this without too much of me running around the house and finding parts. The biggest scare yesterday was the potential loss of the stencil. So it turned out I was like looking through the stuff and I was like, okay, I need the stencil. Why is the stencil not in my box with the bitsy stuff? I could not find it. And I checked everywhere, got really stressed out, even checked if I actually ordered it. So I went on the Stencil website and checked. And it turns out I put it in a box right next to the correct one. So by accident, I put it in the wrong box. So annoying. It's like I try to be organized and keep the projects together and put the stencils and stuff and the PCBs into the right project box. But somehow I was like in a rush or something putting it away, and I put it in the Bitmagic box instead of the iCEBreaker bitsy box. And it's like, oh God. Yeah, so, but I found it after a while. But it's frustrating. That's why organization is important. Okay, so this one is a new part. So last time we used this really tiny 1x1 millimeter RGB LEDs, but I think that was a little bit too much of the awesomeness. So they're cute, but they are fairly annoying to handle. So I decided to go one notch up and do the 2x2 millimeter ones that Greg Deville used for his cubes, I think. Or his geometric shapes, let's call it that way, because it was a dodecahedron, I think, and a cube that he built with the LEDs. Okay, now the fun begins, because I have to check what the pinout is on here. Great. Oh, there is a notch on here. There's a notch on the corner. So that's good. Now let's see. Yeah, we have a marker on here. So that's easier. So that's the RGB LED. Let's hope that's correct. You guys got really quiet in the chat suddenly. How did the SpaceX launch go? I assume some of you were watching that. Very late lunch? Yeah. I didn't have lunch either, so... Oh my goodness. Okay, so you are later than I am. So... It stuck the landing? Very good. I'll have to rewatch it afterwards. I was even thinking of playing it on the stream, having the SpaceX launch run in the background for all of us, but I thought about before the stream and then I forgot, and now I remember it again. So now it's over. So I'm glad they stuck the landing again. That's good. Okay, so do we want to do these? Are these all the bigger parts? Oscillator. Whatever, let's do it just in order. It's not perfect, but okay. So let's do the FPGA. Let's see. All right, dot. I did have my very late lunches a lot in the past. But yeah, currently I only have them late, not very late, it seems. So yeah, after this stream is over, I hopefully will be able to get some chom. Chow, that's the word, right? That's what the kids say today. All right, that's the FPGA. Awesome. bitsy PCF, awesome, awesome. Yeah, so we also need to go to the iCEBreaker playground from Sylvain and add the correct PCF to the bootloader, like the two projects, the one with the RISC-V, that is the actual bootloader, and the I don't know. It's there are two things that we need to synthesize as binaries and then put on the board. I don't even have an adapter at the moment, so that's another thing I have to sort out. Get a pogo pin adapter for programming these. Okay, so right, next. We're getting at least to the big parts now. So that we need the lot. This is the PSRAM chip. Which is now by default populated. The interesting thing is we also added, Jordi added the jumper here on the back. Let's see, can I show you that? So on the back, there is the flash. Oh, you added both, cool. So there's a flash chip select and RAM chip select jumpers that you can disconnect if you want to disable them. I did not find them on LCSC equivalents. I did not see LCSC DFN voltage regulators that would work. So yeah, sorry. Maybe there is, but I have not found them. And I wanted to retain the DFN voltage regulators instead of the SOT23.5s because I wanted a better heat dissipation, especially on this tiny design. All right, that's one. And that's 2. All right, next. So I can put this away. Next one is the flash. We have them on the table here. Flash is huge. What a chunker. So by the way, Winbond is making HyperRAM chips these by now, or HyperFlash? HyperFlash? No, I think HyperRAMs, which are very interesting. So there's even more vendors making HyperRAM parts. Okay, so that's there. So we have a lot of chips on this thing. Oh my god, it's like seeing it in person. Damn, it's dense. Oh man, Jordy, you did an amazing job. This thing is wow. Intense. Okay, so next. So we need the USB ESD protection diodes. Oh god. Okay. There we go. I'm glad. Yeah, I'm looking forward to see you be able to play with it. I really appreciate your help with this. All right, so now we are to the DFNs. So in the BOM we have a mistake here. So the 7533 is correct, but this one is 3312. So I checked that yesterday. This should be not TLV 73312, not 5512. There is no 55 series with 1.2 volt. Only down to 1.7, I think they go, the 55s, and then you need to go to the 3.3, which is then has the 1.2 volt regulation. So I have this here. So this is like, yeah. Well, it doesn't matter. It's believe me, it says 73312, and this is the 75533. This is the same part as on Glasgow, Sylvain. So if you assembled any of the Glasgows, you should have that part already, or the parts already. So I pulled it actually out of the Glasgow box. Map Twitch 15, thank you for the follow. Welcome to the stream. Okay, so this is the top one. This is the 3.3 volt regulator. Yes? Yes. So the top one is the 3.3 volt. And it goes here. Is that the correct orientation? No. Is it? Wait. I need pin 1 indications. Highlight first pin. Yeah, so it is completely on the other side. I would have totally messed that one up. So yeah, it has to go on the right lower. So it is in this case indicated by missing bar, not existing bar. It's weird. Yep. Okay, dot, dot, dot. Come on. Whoa. This thing is tiny. There we go. Ah, I see. So the previous version had only a single one. Thank you, Map Twitch. Hopefully you enjoy the PCB assembly as ASMR or something. All right, there we go. And now we need the 1.2 volt regulator. One, two. All right, and this one has the same orientation essentially. So the right lower corner should be the dot. We see the dot. Oh, the focus is not here, so you won't see it. But yeah, there's the dot in the right lower. Yep. There we go. Oh, that's in between everything. Whoa. There we go. Sheesh. That's tight. There we go. And oh, plonk. That is so cool. Yeah, we didn't, Jordy, we could have gone even crazier and used the Greg DeVille package of these. They also have this TLVs in this really tiny, like diamond-shaped package. It's completely nuts, though. All right, so we have these mounted. Bump, 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 bump. 12 megahertz. 12 megahertz. 20 ppm oscillator. Oh yeah, no. Yeah. No, you know what? We should do everything as just die bonding. So completely have no packages and die bond everything, just like they did with this very early wristwatches that had no packaging and everything was wire bonded. That would be actually really cool to do, to have everything as a wire bond part. Finally, a proper reason for me to get a wire bonding machine. Yeah, not that expensive if you think about it. At least the semi-manual ones. Well, it is a challenge. It's meant to be a little bit of a challenge. All right, so where's pad 1? Pad 1 is in the left upper on this. So this is the 12 megahertz. Oh, I'm out of view here. Sorry about that. There. Yeah. And plonk. This is a little bit awkward. I could have done this like this. And there we go. 12 megahertz oscillator. Bam. Okay, what next? Buttons. So these buttons are the wrong kind, actually. I'm curious if they would fit without me bending the legs for them. Would they fit? Just like that? They actually do. Interesting. So the ones that I'm actually populating on the boards, they don't have the, like, do you see this? So they have this like flat legs here on this package. And the ones that I actually mount on iCEBreakers and other boards have gulling, so, or J-lead. They are bent up, so they don't take up as much space, but also I could pull in the solder paste into a chamfer. So yeah, that's the alternative to do this. And I think this might actually fit as is. It does. So yeah, let's just leave it the way it is. So this is our boot button and user button when the design is loaded. So you hold this down while you're plugging it in so that the bootloader is engaged. But also you can use it in your application when you're done. All right, so that's the button. What next? One thing. Oh, we are done? That's it? The USB-C connector is the last thing. Wow. Then we can reflow it. Bam. Okay, let's rotate. Okay. So the thing that I will have to figure out is if I make any assembly myself is essentially figure out how to add solder paste to these holes. So it turns out that there are a little bit of documentation of paste in hole soldering, where you basically insert paste into a through hole part, but there is no specific documentation regarding any like USB connector or shielding connector dispensing. It ends up being a trial and error. I asked Unexpected Maker or Sion. He did that. Oh, right. That was one of the community updates I wanted to talk about before the stream. Again, I really have to make a list before streams. So check him out on YouTube. There's a full saga about his pick and place machine that you should take a look at. It's very interesting and annoying at the same time. Naomi Wu really was stepped up and is trying to help with the situation, or at least shame a vendor for being a douche. Is this Pro Micro? No. What is Pro Micro? Is that some Arduino thing? This is an iCEBreaker bitsy FPGA development board. All right, so there we go. Let me hold this a little bit to adjust the orientation. Oh God, I think I made a mess. Okay, so that's one. And this is two. Oh, apropos, Jordy, did you see that I fixed the Yeah, you can also send the link to the iCEBreaker crowd supply campaign. This explains what the iCEBreaker in general is and what features it has. But yeah, did you see that I moved the iCEBreaker domains to point to GitHub, correct? Good. Yeah, we need to do some more work on this to add the documentation there. I hope I will have some time next week to fill in some content, but we should coordinate about this. All right, so that's it, I think. There we go. So let's see, can I hold this? Let's switch to the camera. I have to change the orientation here. Oh, la, 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 la. All right, there. Come on. Why is it not working? Lens attachment failed. What? There we go. The lens failed somehow. So this is the iCEBreaker bitsy. There you go. So you have, I will just reflow it in a minute, but yeah, I mounted all the parts. So this is what I'm using is one of the Chinese tea ovens, the 920A, and with all the modifications. I have a blog post on my blog about the modifications. All right, I will put it in the oven and then we can talk about some of the stuff. I'll be right back. I just drop it into the oven. Don't go away. All right, I'm back. So yeah, it should be done in like 7 minutes. So I should probably set a timer for this. So the question was, what is the so there are several questions. One is about the reflow oven, and the reflow oven is a T. Okay, let's do this here. It's the easiest to just find them on eBay. So if you look on eBay for reflow oven, you pretty much get that. So that's T9. So the important thing is you want the A version. So the T962A is the oven I'm using, and I also made modifications to it, which I described on my blog. But it's currently only text and only describes. So yeah, this is the upgrading the oven. These are the changes I made. In the meantime, I recorded video and made photos to expand this description to be actually easier to follow. That's something that is upcoming. I have to find the time to edit the video and put the photos in here. But the materials at least are recorded, so this will be a little bit more fleshed out. I find it pretty, it's one afternoon of work when you don't have to record the video and make photos. And so it's a fairly quick change. You basically have to replace the thermocouple interface chips, and that's pretty much it from the actual hardcore mechanical or electrical changes. But at the end, it just takes one afternoon, and you get a pretty decent oven. I'm using it for production, and I reflowed I don't know, probably thousands of panels in there, so I know it works. The modified ovens like this, I have no idea. A lot of people have them and use them successfully. I don't know how much they hold up for repetitive use. If it is one-off, they probably will do the job. Yeah, so it is a specific intended oven for reflow, PCB reflow, with modifications to make it to get it up to snuff. That's it. The second question was, what is the iCEBreaker or the FPGAs used for? So that's an incredibly broad question. There are some examples on the crowd supply campaign. So if we look at the crowd supply thing, the places where FPGAs shine are things like converting odd protocols from one to another at decent speeds. For example, you need custom hardware that you want to configure. They are very good at that. So you can emulate hardware. I didn't do that. From what I heard, people building from scratch those ovens. It is much more time consuming and involved than getting one of those Chinese ovens and making the mods. That's how I so far have seen. It's like the litany list of I not only have to replace the controller and add knobs and add wiring and add a bunch of different protective layers and blah 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 blah, then it needs additional upgrades because it's still not good enough. And so I felt like I read people having someone in our Discord, he was converting an oven. It took them, I don't know, they are talking about the conversion and tuning of it since weeks now. So it's not like it is an afternoon of work and you can start going on this, as far as I can tell. But it works fine enough for people, and if you have more time than money, then it is probably a choice. That makes a lot of sense. Yeah, I don't know. I have not tried them, so I cannot tell you about the quality of reflow or consistency or stuff like that. But yeah. So essentially, if you get one of these ovens, the process is like this 5 points where you replace the tape on the inside, make sure that the grounding is right, reflash the controller, and wire in the thermocouple interface board. So it's like, that's it. And then you are good to go. You can start reflowing stuff. So you can go beyond that. You can do additional like tuning and whatever, but or PC interface. But yeah, I'm very happy with the T962A with the mods. It's like with just the off-the-shelf thing, I wouldn't be happy, but with the mods that I listed on my blog, I'm very happy with it. It's like I have 2 of them, and they served me for many years now with a lot of reflow cycles. So I'm good with them. Yep. So anyway, so the iCEBreaker bitsy, why we went from the big board to the smaller board, especially, is to be able to embed it into projects. So the things that we do with the iCEBreaker are a very good demo are the LED panels that are somewhere here. So you can drive LED panels with them and being able to shift them really quickly and have updates. This is where FPGAs really shine for applications like that. Doing it with a microcontroller ends up being quite a beautiful hack, but it's still a hack. And then there are other things you can do with them, where you do people are doing SDR radio related stuff with it. People are doing interfacing to telephone line interfaces. People are doing HDMI video outputs, retro gaming console stuff. Yeah, the retro gaming console stuff is really cool. So what, for example, DDR is doing. DRR, sorry. I conflate your name with it. So is that it, or is that his channel? I'm not sure. No, I don't think it's there he is. That's his. No, come on. There. I think now we are on the correct account. Sorry about that. But yeah, this is so cool. So he's building a ICE40 up5K SNES inspired gaming console. Yeah, so he even Mode 7 related stuff is working on his console. I'm not sure why it is such a crusty resolution on here, but this is probably Twitter being just annoying. Yeah, so this is very, very cool, and this is an iCEBreaker connected to HDMI. So this kind of stuff, or making experiments with Twitter compression, yes. So someone even developed, not for the iCEBreaker, but for a bigger FPGA, they implemented full Doom engine in FPGA. So it is like, he also developed a programming language to convert state machines directly so write state machines more easily. So he implemented the Doom engine with it, which is very cool. And a lot of other stuff like camera interface conversion and special effects on video. So a lot of the FPGAs in reality are being used, for example, for machine learning type of stuff. So on cell phones for phase array microphone processing, or for machine learning as in voice recognition for trigger words. So basically localize, you have your iPhone, you do, "Hey Siri," then it will automatically, so sorry for making your Siri go off here, but that auto detection, to keep it on the device, you have neural nets, pre-trained neural nets on the FPGA, and they are very low power, especially the up5K is designed to be low power. and so it like in the background listens to the audio and tries to match the trigger word, and then only wakes up when necessary. So this type of stuff FPGAs are really awesome in. So yeah, let's see. I hope that answers some of your question, because there is so much more you can do with FPGAs. This is one of those projects where you get into that field and you start realizing, oh, I could do this and this and that and this and that. And it's just amazing and really hard to grasp what you can use that tool for until you actually start using that tool for something. Or learn about it and where it is are its strengths and weaknesses. So yeah, I'm very excited playing with this kind of stuff. I'm really looking forward to DRR's retro gaming console. This is what I want to use the bitsy for. It's actually make a motherboard that has sockets, like even this is the cool part about the iCEBreaker bitsy is it fits into a normal IC socket. So it's actually a socket here. So these IC sockets for old computers, this is you can plug in the iCEBreaker bitsy into it, or have this zero insertion force socket like this, where you put it in and close it, and then it's in there. Yeah, things like that. We are playing with a lot of different things. Sockets offering acting as different ISAs. I'm not sure what ISA in this context should mean. So sorry. So I think on the motherboard, I want the motherboard to have essentially distinct locations for the graphics chip, the audio chip, and the processing chip, and maybe some others. So basically use it as a backplane in a sense. I'm still struggling how to do work with this really constrained pin count that we have. Yeah, multi-hardware. Yeah, so it's essentially I want to have a retro-inspired computer where the distinct functions are on separate chips for understanding purposes, so that people can understand them easier, and also to keep them physically separated. Even though you could do it in HDL, you get more capability this way. I think it could be an interesting teaching tool. So it is more, yeah, it's inspired like by C64 or something, where you have a memory bus and you have multiple chips that are specific purpose. And so you can work on just the processing, or you can just work on the graphics part, or just on the audio part separately, and they are separate chips essentially. I don't know, if it doesn't really make much sense, to be honest. It's just a thing where it's like, oh, that would be cool, especially considering that there are some YouTubers that want to build their retro computer using chips. So maybe a hybrid even approach, where you have some chips being still old chips and some of the chips being FPGAs, might be an option. So the problem is like most of the old chips are 5-volt I/O, so you would need to level shift this, and the iCEBreaker bitsy is 3.3-volt I/O. Yeah, I don't know. It's also you have a smaller bus, so we would be limited to like 8 pins for the system bus, or 8 I/O lines, so 8 lines of whatever goes over them. And I'm not sure how, because the major limiting factor is the video output. So HDMI, to have like a reasonable amount of colors, more modern amount of colors, you need 16 bits or 16 lines of data. So essentially, yeah. Yeah, this is the question. It's like we do things that we just do because we do them. because because we can, and then you figure out like what actually makes sense. So yeah. All right, I think the reflow should be ready. Let me check on the oven. So I'll be right back again. There we are. So this is it. This looks cool. So yeah, it's a tiny bugger. So this is the full-size icebreaker. That's so cool. So this is what I was talking about, the socket. So this really just fits in here. So we could just plug it in. Chunk. Man, this is cool. I need to solder the USB-C connector shield now by hand, because this is not reflown. Now let's look at this under the microscope. I assembled only 2 for now. I have enough for 9, and I will assemble them off stream. Microscope, and screen capture can be disabled. Alrighty. So let's see. Let's inspect it. So this looks good. The voltage regulators look good. I was a little bit concerned with there. Okay, that looks cool. The FPGA looks good too. No shorts. It's very easy to inspect the QFNs. That's the fortunate thing. And then we have this, which is pretty boring large stuff. Okay, cool. So now let's look at the other board. That's looking good too. Should zoom out a little bit for you. So shiny. So shiny. There we go. It's looking good. Ah, very good. Cool, cool, cool. All right. So let's solder the shield. Should solder it from the back or the front? That's the question here. I think it should be fine. Let me take this, the silicone mat. The silicone mat, switch on the soldering iron, and then should be able to just wick it in there. These holes are bigger than they should be, I think. It's like this is like hanging out in the middle of like, see? What's going on? Why is the video broken? Did it get stuck? No. Why did the video stop? Yeah, what happened here? Oh no. Can I do something about this? That's annoying. Oh, super annoying. Why did this do that again? I have that happen sometimes. I think it's like somehow this is crashing and I don't know why. Should I just risk and unplug it and plug it in again for hoping that it will reconnect? Let's see if that... Test. Okay, I should be back. You should be hearing a very loud fan now because I have it running in the background. Okay, so yeah, the problem is this was getting video from a capture device instead. Yeah, so if I switch this off, oh, come on. So that should be better now. That is just the air. Is that good? Oh, it is clipping now, right. Now it's clipping. Let's see. There we go. That should be better. There we go. No clipping, hopefully. Okay, awesome. So we fixed this. On the fly tech fixing. All right. So yeah, now let's see how loud it is when the fan is running. Okay, cool. Thank you. Sorry about that. Come on. I don't want to get it on the ground pad if I can avoid it, to keep it clean. There we go. Another thing that I can imagine the iCEBreaker bitsy, the regulator are annoying. No Farnell, no DigiKey. Should I put some in an envelope and send it to you? DFN shouldn't be that hard to find, to be honest. It's like, it's not, I would not think that it is a super rare part, and it's also a TI part. It's like, can you get them from TI directly? Who is the European best reseller for TI parts? That's the question to be had here. Oh, for free shipping, yeah, the minimum order. If they didn't have that deal that you get free shipping under $50, it wouldn't be as much of an issue. I know. It's just reverse logic here. Sorry. Yeah, that sucks. I'm sorry. I wish FedEx wasn't charging that stupid extra fee for handling. I wish I had them ready when I was sending the stuff to the German store last week. Then it wouldn't be as... I have stuff to send to Germany anyways. Maybe that's the option. Maybe I will send the bitsy in my next shipment to Germany. So that we can send it to you from there. Would you rather get just the regulators from me or the bitsy? That's the question. Yeah. No, it makes sense. I understand. That is a reasonable request there. Cleaned. Okay, so now we have these done. All right, so the problem now is I don't think I can continue not having a programmer for this because I need data, so the whole SPI interface, CD-on, CDS, CRST, ground 3 volts. I don't need these two here, but I definitely need all this 8 here. So I need some kind of a pogo pin thing. So let's see. We are now past time, so we will probably not do it today. But yes, a 2x5. No, I might, but I don't really want to solder it, and I'm afraid that if I just press it against it, it will be too annoying to use. But what I was thinking of doing is actually get a connector and use pogo pins that are plugged into the connector. I just have to do some searching and use these holes as locator pins. So let's see. There we are. So I was thinking I will make take a header that's like a 2-row header, and then use these as locating pins for the pogo pins, and then the pads should be aligned directly. So then I would have a thing that I can just press against here with nice location and use pogo pins for good connection. It should be totally doable. I could solder one for testing purposes to bring this up. That's definitely doable. But I think I will just dig through my stuff that I have here and see what I can come up with. So either, is it 3 rows? It's not 3 rows. It's 2 rows. Why is it 3 rows? One pin away from the first row. Oh, you mean, huh, interesting. So you don't think, oh, you're right. You're right, it will not reach there. Huh, you are correct. It's 1 row away. Right, you are correct. That's a bummer. Oh, but I can use these then. I can use these as an alignment pin. So I can make it 5 pin and then use these as alignment for the just not connected alignment. It will not work as soon as I solder in connectors in here, obviously, but for initial bootloader programming, that should be good enough. I can even locate it on both sides and have like a really long connector that has pogo pins, and then do that. That's actually not bad. Yeah, that's doable. So cool. Yeah, I will have to come up with the correct connector, maybe even order something. And then we can make a pogo pin tester and program it. So depending on how things go, regarding the programming, I was thinking we might actually stream this Thursday again, so that I can get that going and get that out of the way. It really depends on when JLC PCB and LCSC will deliver parts for the tie guard. So tie guard this thing. So the next revision, I have to assemble that. Essentially, as soon as the parts arrive for this, I have to basically 24/7 work on this to get this done, because Joe needs it for Black Hat. So that really depends on if that gets delivered or not. So yeah, I will be definitely programming it and trying the bootloader as soon as possible, and we'll try to let you all know how that goes. I do think I should probably stream it when I do, so that you can see the bring up, because that's always a pretty exciting process of either it just works or it's so Black Hat it's not Black Hat, it's Black Hat. This is Black Hat is doing courses still, so even though they canceled, they are doing remote classes. So very few people, unfortunately, but still a few people subscribe to Joe's class and are taking the class, so he has to send them the hardware necessary for the workshop. And they will be basically remotely doing the workshop with the hardware. So Tigard is part of that. And so if you have an employer that is paying for courses, it's like I assume there are still places available. So maybe you want to support Joe that way. Anyway, so that will be happening. I will talk about this after we finish with the stream because it's more of a community update thing. So yeah. Anyways, just check out Unexpected Maker. He had issues with a pick and place machine. So yeah, I will talk about this here. Xeon is essentially going through a long-winded way of setting up doing manufacturing himself for his products that he makes. So what is it called? Not teensy, but he made this ESP32 dev board, a small dev board, and he was manufacturing it himself. It was a crowd supply campaign. And he used no MCU. It's how is it called? Unexpected Maker. He ESP32 Tiny Pico. Yes, there we go. So I can show you how this looks. So Tiny Pico. So this is this board. It's pretty much what the iCEBreaker bitsy is, just with the ESP32. It's a very cool board. I am planning to use one. I have one of these boards from him. So I was planning to use it for a wall clock using the LED panels and the iCEBreaker bitsy. So this guy plus the Tiny Pico to make a LED panel wall clock. So that's a project that I had in mind, which would be really cool, having these two next to each other. So this would drive the LED panel and do the frame buffer and whatnot, and this one would be connected to the internet and keep timing, and use and have like configuration interface and whatnot. So that's a thing that I would love to build at some point. Anyway, so he is actually assembling them himself, just like I do. I have a Quad 4000C pick and place machine, which I bought from GoPPM, GoPPM. So this is what I have, is essentially an ancient machine that is designed from the early 80s and looks like this, and it is completely refurbished. It was basically torn down completely and rebuilt from scratch with a modern quote-unquote computer. So the original control system is running on DOS. They updated it to Windows with a newer software. It's a workhorse. It has its quirks, it is slow, it has its issues, but it is a proven old machine that actually works, and it's very accurate and works, just keeps working. You do learn from every machine. It's like baby, like you have to like tend to it and do stuff and whatnot. So Xeon, he got instead, because he's in Australia, so the market for like second-hand old machines like here in the US is not big. So he instead got one of the Shanghai pick and place machines that are one of the desktop ones. So he spent many months tuning it. It's like he even says himself, it is a piece of shit. Sorry for the language, but it's not a good machine, but you can tune it to use and make it work. And for the money, it's like $4,000 or something like that. It's a bargain. So he was using that, assembling his Tiny Picos, and then he got for a loan, I think, a Neoden machine, which he liked, but he had to return it for some reasons. I don't exactly remember what the reason was. And then he went through another loop. It's like, I need a faster machine that is more capable. So he got a big Shanghai machine. And that thing arrived, and the first day he tried to set it up, and essentially the feeders that it came with are incredibly inaccurate and wobbly and floppy. And every time it loads a part, the part like flips inside the feeder, which is completely unacceptable. This must not happen on a feeder. It's like, and then when he contacted them, they were like, so first they wanted to dismiss him. Then he went on and was like, no, this is an issue, you have to fix this. They tried to make him like modify the feeders. Eventually one of their engineers admitted that it is a known issue, and then he was really up the wall. It's like, why didn't you tell me before I bought this thing? It's like, it's $14,000 or even more that I spent on this, and it's not fit for purpose. So they completely stopped talking to him because he was like, no, I want a refund. This is ridiculous. And they were like, well, then send the machine back to us. And it's like, I would be spending as much money as the machine is worth in shipping it back to you. You have to pay for it. It's like, oh God. Anyways, horrible service, horrible company. Naomi Wu heard about this, and she also wrote them a letter, and she made a video recently. And it's like, and essentially he has no recourse because he had to make a bank deposit directly to them. So there's not even a way of getting the money back, like force the money back from them. It's just, what a saga. It's just, everyone should know, if you are thinking of pick and place machines, don't get a Shanghai. They are scammers and they are trying to rip off people. I heard similar issues with Shanghai machines, the simpler ones. It's like people were trying to port OpenPNP to their software because their software is terrible, and they were very uncooperative and stuff like that. So yeah. Anyways, it's a black sheep in the industry. So it's like, don't do business with them. Check out his videos, they're very interesting. He goes in detail. He tries still to fix and adjust the machine. He's using it somewhat, but it's like the fact that he has to basically take every panel he takes off the machine and hand fix parts on the thing is completely unacceptable. This is not what you pay for a pick and place machine. It's like, my machine was pretty much 2 times as expensive as that. It is way slower than what the other one is promising, but at least it's reliable. It's like, oh man, just bad. I heard better things about Neoden, but there were some limitations that's why he can't use the Neoden. And the Neoden is twice as expensive as the Shanghai too. Anyways. Yes, yes, at least you can use it. All right, so yeah, that's the story there, and you should check it out. I really applaud Naomi for stepping up there and using her ability to talk Chinese and know the culture and having a connection there to actually also step up and help out. This is as a maker, designer, hardware hacker, whatever you define yourself as. Community, we are very small, we are very few people, we have very little money, and if things like this happen, it really hurts. And it's like watching his video for me was very anxiety inducing, because I had close calls with my pick and place machine too, and it's like essentially he has to live with it and he can't even fix it, which is so bad. Well, he hopefully will fix it eventually, but yeah. Anyways, so that's the story. If you have more questions, ask me, and there's probably more to tell, and gives your support to Sion. All right, so let's go back to the other screen here. So where were we? There. So we assembled the iCEBreaker bitsy. That was the goal for today. I really want to see it. There we go. I'm very excited. This is very cool. I'm really curious what we will build with these. I think we are getting close to, if this all works out, I think we are very close to making a small batch. I am still pondering if we should make a campaign for it. I think we should just make a small batch of them and put them in the store so that some people can play with it and kick the tires of that design. And maybe we will do a crowdfunding campaign for this, a simple one, a very, very simple one, with no huge time investment in all the documentation stuff and actually get this out the door, which I think would be very cool. All right, so yeah, thank you so much everyone for being here. This was a little bit longer stream for sure. We will be back probably on Thursday if everything goes well. If not, then I see you on Tuesday again. We will be hopefully setting these up and getting them up and running. I need to figure out the interface and the pogo pin. I will definitely tweet about this and share it on Discord, so join our Discord. It is being here linked on a regular basis. And you can see it also, the link for the chat is down here. So 1bitsquared.com, pages chat. Join our Discord. I will be sharing what the progress is, if any, between the streams. And as always, thank you everyone who is subscribed to this channel on Twitch. It really helps financing stuff. It's all requires resources, so thank you so much. If you, it's always will be free, this content here, but I really appreciate the support. Also, thank you so much for the Patreon supporters. I have a few people that are on the shout out tier, and I would like to give them a shout out. So very big thank you to Aki Van Ness, Jamin, Brennan Ashton, Ben Venick, Drew Fustini, Edward Borden, Go Jimmy Pie, Jeff Wang, Jordi Parky Rodriguez, Kelly, Matis Schmidle, Matis Pritchett, Miha Benovets, Sean C., Tom Keddy, and Sid Price. So thank you very much, everyone, for supporting. And I hope to see you very soon. And yeah, as always, if you have been, thank you for watching. Bye.